Thank you, everyone, for joining us this afternoon for a discussion on strategies for engaging students in new ways of visualizing and thinking about expressions and equations. Our presenters are Tom Dick and Dan Ilaria. Tom Dick is a professor at Oregon State University and an author of the Building Concepts lesson series. And Dan Ilaria is a mathematics professor at West Chester University of Pennsylvania and also an author of the Building Concepts professional development series. Tom Dick will discuss our agenda.
Hi, everybody. Glad you're all here. Dan and I are going to be sharing with you some thoughts about algebra, and especially expressions and equations, and in particular building concepts. This is a project that's developed over several years, and it's free resources for teachers and for professional developers. And today we're just going to share a bit about that, what it's about, and Dan in particular will take you through some of the electronic documents and his experiences with using them in professional development. Let me go ahead and say a little bit about building concepts and where it came from. It's, as I said, it's electronic documents authored on TI-Nspire. They're really self-contained. They run on a number of platforms, computer, iPad, and of course the TI-Nspire handheld. These are not algebra files that are just for procedural practice. It's building concepts is, as the name suggests, really trying to center and focus on conceptual understanding of algebra. And so there's a really close look at equivalence, both in terms of equivalent expressions, equivalent equations, and rather than just practice on algorithmic skills, there's really an emphasis on reasoning as a strategy in solving equations, an emphasis on algebraic structure. And in looking at building concepts, we've really looked at the research literature pretty closely and thought deeply about the kinds of misconceptions students have in algebra, and we try to confront those so we can correct those and build really robust conceptual understanding. Also, these files are a bit different than just kind of the one-off applet you might find on the web. The building concepts, it's actually a large suite or sequence of files that build from early algebraic understandings in the 6th grade all the way through 8th grade. And they're based on the research that's gone into learning progressions for students in algebra. And so we hope to give you a sense of that as we go through this. We sometimes call this a spaghetti diagram, but it's just a mock-up to kind of give some idea of the learning progression and the structure of expressions and equations in the Building Concepts series. Really what we're trying to do is leverage off students' understandings from arithmetic and help them progress into algebraic understandings. And that's done through this kind of dual weave between expressions and equations and the interplay between the two. Expressions, there's attention paid to notations, operations, and exponents, and that develops into more advanced looks at, for example, positive and negative exponents, fractional exponents, radicals, scientific notation on the expression side. On the equation side, we're looking at the idea of what it means to be a solution to an equation, and then taking students through strategies for solving equations that are very structurally based. And so there's a lot of attention to linear equations, tying that to proportional reasoning, and then multiple representations, thinking about graphs, and then progressing to systems of equations and quadratic expressions and equations. So that's kind of the very quick spiel. You know, the things I would emphasize in general is that it is a sequence that's meant to be coherent and build on students' understanding. And as we go through, I'm going to turn it over now to Dan. Dan's had a lot of experience in using the files, both with pre-service teachers as well as in-service professional development. So I'm going to pass control over to Dan Ilaria, and he can take you through some examples.
Thanks, Tom. Hi, everybody. Thanks for joining us this afternoon. I've been fortunate enough to be a part of this project. As Tom said, it's developed over a couple of years. And so I've been able to pilot these with my students in my pre-service teacher classes, and it has really transformed the way that I've been able to help them learn about these ideas. So I'm going to be switching over to share my software with everybody. So as that happens, I'll also mention that over the past year, I've worked with a group of in-service teachers from the Philadelphia School District. We met pretty much every other week virtually, and we talked about all of the different building concepts. So it was great to get some feedback from them, how they were using these files with their students. So I'll share some stories as I go through this over the next 20 minutes. So the first thing that Tom had mentioned was about the key ideas behind the building concepts files. The first thing is conceptual understanding. And so these files are really meant to help students get that foundational understanding of an idea, and then the teacher can take it from there. So think of it as an opportunity to kind of supplement an existing curriculum. I know we have a lot of supervisors on there. I was a former supervisor in New Jersey before I came to Westchester University. So having that former lens, I see a lot of benefit from this, because Tom had mentioned it's a whole suite, but there are also teacher files that explain things like how to lead a discussion at the beginning of class, key questions to ask, their student handouts, student exploration materials. So it really is a full package. So there's the conceptual understanding piece, and there's the addressing misconceptions piece. And working with pre-service teachers, I get to experience all of these misconceptions every semester with each group of students. I think when I no longer come across these misconceptions, it's time to retire. So one of the first things I actually ask students is the name of this first file, which is called What is an Exponent? And the number one answer I get from them is that it's the number of times a number is multiplied together. Does that sound familiar to everybody out there? I'm going to ask some questions, and everybody can respond in the chat. I have it open on my screen so I can see your responses. But I'll say that again. You know, my typical pre-service teachers, I'm working with teachers who want to be certified in grades 5 through 8 in Pennsylvania. And I ask them, what is an exponent? And they tell me it's the number of multiplications, number of times a value is multiplied. And so I have them open up this file, and I have them go to page 1.3. We use iPads in our class because I don't ask them to buy the technology, but we do have a nice set of iPads, and we use all the files on there. It works great because I never have to teach them how to actually use the handheld. It's all very interactive. And so I show them this page, and I say, okay, think about your definition about the number of multiplications, and I'm just going to click up and down on this screen and think about your explanation about how many multiplications there are and what the exponent is. You know, not much happening on this page. I'm just clicking up and down. But all of a sudden, they realize, wait a second. I just said 4 was the number of multiplications, but there's only 3 multiplications on there. And so right away, we've addressed this misconception of what an exponent, of what they thought an exponent was. They may be able to say, okay, well, can you write out 3 to the 5th for me? And they would probably write it correctly. but their language isn't describing what they're writing because they're talking about the number of multiplications. And so this is where we start. And immediately they go, oh, wow, I really need to rethink about this. And so the great thing about this file is starting off with addressing that misconception, that understanding of what an actual exponent means. And we, as a teacher in a classroom, do not have to say anything to our students. They can look at this page, they can play around with the exponent, they can change the base to whatever they like, and explore, come up with a definition of themselves, and we can talk about it and make sure that they understand that the exponent is talking about the number of factors, not the number of multiplications. And once we're kind of set up there, what I do with my students, and it's actually what we do in the professional development, is tell them, well, let's look at the next page. And what would be some things that students can learn using this page? So let me ask you to type an answer into the chat window. We're looking at this page. I have 2 calculations. I can change my exponents as I did on the previous page. And so what are some ideas that we can come across for our students that they might take away from this? And I've always enjoyed, whenever I've done this in a PD, listening to teachers talk in groups about how they could see the benefits of this for their students. Again, addressing some misconceptions, but also I try and get them to think earlier of, well, what about building the concept? Remember, they don't understand this. They haven't been exposed to it yet. I can change the values again of my base. So some people have noticed, you know, this starts to get us to our exponent rules, right? So here we have a multiplication. I have operations down here at the bottom. And so I can change from multiplication. I can click on division. And so now I can have my students explore and say, huh, does this relationship work for different operations? What do I see here? And I like a response that I just saw about it's 2 ways of expressing the same idea, because one of the things that Tom had mentioned earlier, that we're trying to focus on this idea of equivalence as a key understanding throughout expressions and equations, the whole series. So it looks like this works for multiplication and division. What if I change it to addition? Ooh, now I see something that's different. And so something for students to talk about, right? And I just saw, I'm going to check subtraction too. I see, that doesn't work. It is pretty interesting that the subtraction, the second calculation, is larger than the first calculation, but in addition, it was the opposite way. Is that always true? Things to kind of explore from kids. If I go back to multiplication, another fun thing for my pre-service teachers when I get them to talk about language, because we know vocabulary is real important. We have that mathematical practice about attending to precision. Somebody mentioned distributive, right? The distributive property of exponents versus the distributive property of multiplication over addition. There are different types of distributive property, and so we need to be precise in how we communicate those ideas. So it's really eye-opening to my pre-service teachers to understand the subtlety in the language that they use when talking about an idea that they think they understand, that they're about to go out and teach. And it's really very hands-off on my part and letting them explore, which I think is one of the really nice things about these files. Let me jump to a second one called Building Expressions, which is a little bit further along in the sequence. And here the idea is when we do the professional development, we actually start out with a problem to make connections between numerical tables and algebraic expressions. And so we kind of start out with this idea of there's a person who has a certain number of stamps. And then we say, all right, this other person has 5 more than twice as many. Okay, so you know, if Sue has X stamps and Pat has 5 more than twice as many as Sue, what would that expression be? And so we have students build a table on paper and then say, all right, can we write that expression? So I think 5 more than 2 times what the other person has. You know, I think this should be the correct equation. I hit submit, and I now have this number line where I can evaluate my expression for different numbers. I can drag along this number line and see different integer values. And I can now check my expression against my numerical table. And as we start to help students make connections between those, we can start to look for patterns, start to look for ways to be able to use the table to write these expressions, really kind of bridge that connection between the numerical and the algebraic expression. So that's the building the conceptual understanding part of that. The other fun part of this file, which my teachers in Philadelphia absolutely loved, they could not talk enough about this after they showed it to their students, was this page of 2 expressions and being able to address misconceptions. So I'll give you an example. There's a lot of students, right, will say, oh, well, what's the difference if I write 5 minus x or if I write x minus 5, right? They should be the same thing. But now, when I click submit, I bring up that number line. And this one is set up for positive integers. It's meant to be addressed in 6th grade. There are 2 more pages in this file that addresses negative and positive numbers, meant to address, be worked with in 7th grade, which is one of the really nice things about the building expressions also, is this collaboration among grade levels about how to work and build a coherent curriculum across 6th, 7th, and 8th grade. But now students can now test for themselves whether or not these ideas are the same, right? So this is probably a mistake that you might run across. Give me some other examples of mistakes algebraically that your students encounter, or you encounter your students making, and let's see if we can test them here. While I'm getting some answers, I know I will share one of my, what I think is probably another common mistake. So distributive property, right? And what do most of our students do? 2x plus 5, right? That's probably common. And so I click submit. I can test it. I see immediately it's not equal, still not equal. I can test all these values. It always seems to be 5 away from each other. How come? What's going on here? You know, we can ask students all those sorts of questions as well. So we have so some suggestions. We're dealing with squares, and I do have an x squared in here, but Tom, we can't do any exponents in here, right?
Not just the general ones.
Yeah.
Just do the x squared.
Yeah. So I think people are thinking about the quantity squared. Students have trouble with that. But we can also maybe test something like this, like kids who want to factor x squared plus 9, and they go, you know, x plus 3, x minus 3, and they can just, we can also type this in. I like the dragging part. I think it's a good visual for students, very tactile, great with a smart board or some other interactive type board to have students be able to pull these down. So are those 2 things equal? Doesn't look like it. We could test that. Someone had mentioned subtracting a negative. So yeah, we can check that out. Is 5 minus, let's see, try it like this, right? Minus negative x, and do 5. Maybe demonstrate that this does work. Right, so you can see, oh, those two expressions are equivalent. How come? What's the reasoning behind that? So we've got some good ideas and definitely some different things that we can explore. I think the negative sign in front of the parentheses is also always an issue. And now, one of the reasons my teachers in Philadelphia that I worked with really liked this was because they would, when their students would make a mistake, they would have them put this on this page, and they would have them test it. Or if they did, one of the teachers had given an exam on simplifying expressions and then looked at the results of it and saw a common mistake and then gave the students a couple of examples and had them test them on here to see which ones worked, which ones did not work. So that was really helpful. And it made me kind of remember, oh yeah, you know, as a supervisor, you get all that test data and you can maybe look at it and address some misconceptions, and you see what the issues are. And so you can pull this out and take care of some misconceptions that might be happening across a couple different algebra classes, or maybe something that students bring to their Algebra 2 class or to their Algebra 1 class, and really address those sorts of things. It's also, I don't know if anybody's heard the expression of favorite mistakes. We can kind of take a look at it from a favorite mistakes perspective and have students explore and check for themselves and think about why those mistakes are happening rather than just saying, no, that's wrong, here's how you have to do it. So the third file I want to share is about using structure to solve equations, which my pre-service teachers, their response to looking at this and thinking about solving equations this way is always, why didn't I know this before? Why wasn't I taught this earlier? So in making the connections, think of a problem like this where it's from elementary school, some kind of missing factor, 6 times something equals 36, or a missing add-in problem, 5 plus something equals 9. This missing factor or missing add-in idea is what's behind this whole idea of using structure to solve equations. And so we're trying to connect what students have learned in elementary school to algebraic reasoning. And one of the really nice things about this that I try and emphasize with my pre-service teachers is you're getting students to think about how to solve equations algebraically without worrying about the notation. And the teachers in Philadelphia said they could get another group of their students to be successful at solving these types of equations if they didn't require them to write down the notation because they thought about it. So here's how this works. I have 2 times the quantity x plus 6 is equal to 50. So I can think of this as a missing factor problem of 2 times something is equal to 50. So let me highlight 2 and this box of something and say I want to select that. And so 2 times what is equal to 50? It must be 25. So I'm going to submit that and I get yes. So now I've changed it from a missing factor problem to a missing add-in problem. Something plus 6 is equal to 25. So one thing, common mistake for students, type in 31 because they're thinking 25 plus 6. And, ooh, I did that. I hit the wrong button. And so if they type in 31 and I hit submit, it tells them, nope, that's not correct. So let me go back. Oh, I should subtract. So let me select that and say, if I subtract that, it should be 19. Yes, that works. So we get to think about these problems of, oh, well, if I was doing this, one option would be divide by 2. Another option would be subtract by 6. We could write that out algebraically. But with this using structure, we get students to think about these ideas without dealing with the notation. So there are a couple of set problems that are available. So take this sort of problem, for example. Is it 2 something divided by 3 is equal to 6? Is that how I want to think about this problem? Or do I want to think about it as 2 times something is equal to 6? And I can select either one and work through the problem. The other option is something like this, right? This is one of the problems that I typically give my pre-service teachers, and I just watch them, and they all distribute by 3. They all distribute by 5, and they do all this simplifying. And then I have them stop and go, let's look before we start doing some calculations, before we dive into algorithms that we've been so ingrained with. What's the same? Don't I have 3 of something plus 5 of something? Isn't that 8 of something? Can't we just think about another way of solving this rather than just going through those algorithms? Hey, they work. We can be really efficient with them. But sometimes there are other efficient ways. So it's really getting students to think about what is going on with our problem before we start just blindly applying things that we see, right? So this answer would be, I should put Tom on the spot, right?
Well, let's see, 3 plus 5, maybe 7?
8 of something, 8 times something is equal to 7. So that works. And now we're back to that missing add-in, right? Of something plus 5 is equal to 2. So that's the idea behind the files. You can see, as I stop sharing this, that each one of these examples I selected because of those 2 ideas of helping with the foundation and the concepts, building that understanding, and then leading to that procedural fluency that we need students to get to. This is all of the possible files there are in this expressions and equations series. And they're not all meant for 6th grade or 7th grade or 8th grade. This is really a way to collaborate among grade levels and talk about common ideas and build upon each other so that kids get that coherent story that they're working with. And in my experience with the professional development, both with my pre-service teachers, they're obviously meant to be learning the content, but with the teachers I work with in Philadelphia, their understanding of the content that they were teaching also changed, which I think is the fun part for me of working with in-service teachers in this professional development, is deepening the content at the same time as finding interesting ways to expose kids to these ideas that make sense, that uses reasoning. It's all in there in the package, and that's the way that the professional development works. So I hope you found something useful. All this is available on the website. I'm going to let Mike Houston take that over. Thanks, everybody, for listening.
Thanks, Tom and Dan. I'm going to go ahead and bring you to that website. If you just go to our website, education.ti.com, one way to get there is to go under Activities, and you'll see about a quarter way down is Building Concepts in Mathematics. And so you can see that we have a few different Building Concepts series, and within these, let's say you choose fractions, for example. These are all the activities that have been written, and you can see the varying grade levels and concepts. All of these activities come, again, complete with a student activity, teacher notes, the TNS file, which is specific to use on the TI-Nspire, and again, these are all free. So if you liked the brief glimpse of what you saw today from Tom and Dan, please feel free to visit our website and check out more of these files. They're really excellent. We're excited that the T-Cubed International Conference is coming to San Antonio this coming March. It's a great way to meet with people like, for instance, Tom and Dan, to learn more about building concepts, about technology, say TI-Nspire technology, and just make connections. So I go every year. I really love the conference. I hope to see everyone there as well. As I believe Tom mentioned early on, we are giving away to one lucky winner a conference registration for 2. And tonight's lucky winner is Doris Gast. So Doris, congratulations. We hope to see you there as well as everyone else. And we'll be in touch over email in the coming days to give you a little more information about that. To receive a certificate of attendance for today, go ahead and click the link in the chat window. Also listed is a link for the documents. And in case the links aren't working or in case you missed something, you're automatically going to get a follow-up email in a couple days. And in that follow-up email, you'll get a link to the recording, a link to the certificate, and a link to the documents as well. So thanks so much, Tom and Dan, for everything you shared today. I know it was a quick 30 minutes, but there were some really great things that was discussed and some great conversations with everyone else out there. So thanks so much for joining us. We hope to see you back online real soon. Have a great afternoon.